All right, ladies and gentlemen, we have finally come to one of the biggest pages here of the test. Not the final test or final page here, but this is page 4. It's going to take a while to get through this here, a lot of explanation, and your reward is that video number 5 is pretty short. So what we're going to do here is go through the story problem that deals with a slope and a y-intercept. In 2002, the population of Augusta was about 950 people. These numbers are made up, by the way. By 2009, the figure had grown to 1,014 people. Let P of t represent the population t years after 2002. Now, what's important about that is that some of you might say, oh man, just like the card shark problem on the first page, let me just set this equation up. And you'd be partially right, because you should have your x as your time and your y as your dependent variable, or your population in this case, but it says t years after 2002. So this becomes our 0 year, okay, and this will become our 7th year. Almost wrote a 9 there. Oops. Because it's 7 years after 2002. This is 7 comma 1014. So what this means, we are going to find the slope. Now it says find a linear function that fits the data. We're going to need to find our slope, m, and we're going to need to find our y-intercept, b. Now we actually already have the y-intercept. It's right here. So our y-intercept is already found for us at 950. So that means the population will start at 950 at time 0, or 2002, and then 7 years after that it will grow. But how fast is it growing? Keep your calculators handy, because I am going to use a decimal approximation for this, because if I'm going to use my slope equation, which is y minus y over x minus x, I know the book used subscripts there, I will take my 1014, which is my y value, subtracted from my previous y value there, and have this as 7 minus 0. Now if I do the subtraction and then divide by 7, what I get is an approximation where my slope is approximately 9 14/100ths, or 9.14. So now that I know that my approximate slope and I know my y-intercept here, my equation is going to be P of t, or I would accept y equals if you'd wanted to. P of t, or y equals, is equal to 9.14x plus 950. All right, now it says use your function of part A to predict the population in 2012. Now, that means that my x is going to be not 2012, but 10, because 2012 is 10 years away from 2002. So I'm going to go into my equation, P of t, or now P of 10, is equal to 9.14 times 10 plus 950. You also could have written y equals. It's, again, both of these, again, it's just, personal preference here, but you can see the way I wrote it that you can plug 10 in for x and get an answer of 91.4 plus 950. That's what you get when you multiply 9.14 times 10. So 91 and 4/10 plus 950 is 1,041 and 4/10, or an approximate population of 1,041.4 people. Okay, let's take a look at problem number 17. All right, it says, oh boy, let's put both of these on the same screen here. All right, here we go, folks. Write an equation of a line in point slope form. Okay, just first of all, a little bit of a note on this. I will allow you to use, instead of point slope form, you can use slope intercept form. So yeah, you can kind of ignore this and write y equals mx plus b, and use that instead. I know you're probably going to be better at doing it this way, and that's the way I wrote my answer key anyhow. But it says it has to contain the specified point here parallel to this line. So what my first job is to find out what the slope is of this line, and then I will use the parallel slope of that line and this point to find my y-intercept of my new line. So we're starting with this old line. We're going to get everything equal to y, so 2x, subtract that from both sides. So I get negative 3y is equal to negative 2x plus 5. Divide both sides by negative 3. Notice when I do that, I'm doing this by every term. So Here I have y is equal to negative 2 divided by negative 3 is positive 2/3 x minus 5/3. Now, here's the first part of the problem. I have just taken my first line, solved it for y, so I now know my y-intercept. Sorry, now I don't know my y-intercept. Now I know my slope, and my slope is 2/3. Now the parallel slope to 2/3 is 2/3. Parallel slopes are the same as the slope of the original line. But we don't know the y-intercept because this is the line that parallel line has to go through. And, well, we need to actually plug and chug and get this to work here. So we are going to find my new y-intercept by plugging in everything we can into y equals mx plus b to solve for b. So I'm going to plug in my y, which is negative 5. I'm going to plug in my m, which is going to be, in this case, 2/3. I'm going to plug in my x, which is negative 4. And then I'm going to plug in my b, which is b. Okay, use a little multiplication of fractions, top times top, bottom times bottom, plus b. I'm now going to get this b by itself to find my y-intercept, so I'm going to add 8/3 to both sides. Now, adding 8/3 to both sides is pretty easy, but this is a whole number, so I'm going to make it into a common denominator, negative 15/3, which is the same thing as negative 5. So my negative 15/3 and my 8/3 gives me a total of negative 7/3. That's right, b is equal to negative 7/3. And so I get from my final answer here, my equation y equals 2/3 x minus 7/3. So let's review the steps that we went to do this problem, okay? First thing we had to do is take this equation, get it equal to y, find our y-intercept. This said parallel, so we're going to use the same slope. Then we take the point and the slope to solve for the y-intercept. Once we have the y-intercept, we can plug that into our equation with the slope that we found previously. Whew! Well, how could this get any worse, right? Well, if we are using perpendicular. You see, this is the same equation, the same line, but this is going to be perpendicular. So what this is going to, like, I am not going to go through the steps here, but you can see from up above we would get our y equals 2/3 x minus 5/3. Okay, so what does perpendicular mean? Well, the perpendicular slope wouldn't be 2/3. It would be negative 3/2. All right, so now we have a new y-intercept, same point though. So when I go to my y equals mx plus b, I'm going to plug in my negative 5 for y, plug in my negative 3/2 for m, and my x is going to be negative 4. I'm having a tough time when writing my 4s. So negative 5 is equal to, now this is going to be top times top, positive 12 times over 2, plus, come on, right, well. So negative 5 is equal to 6 plus b. Subtract the 6 from both sides. Negative 11 is equal to b. Well, this is really nice. No weird fractions like in the previous problem. So y is equal to our new slope, negative 3/2 x minus 11. Let's review. First thing I did is I got my equation where my y is all by itself, and that was the same work up here. So y equals 2/3 x minus 5. Now, I need the perpendicular slope, not the parallel slope, perpendicular slope. So this is a negative or opposite reciprocal. So flip it on its head and make it opposite of what it once was, which made it negative. Then we are going to plug the new slope and the point into this equation here and then solve for b, which was a little easier than the last problem because it didn't have so many fractions. Okay, now we're on to our last two problems of the page. Told you this would be a long video here. So here we go, problems 19 and 20. All right. So what we're going to do here is we're going to find the following, f minus g of x. So what we're going to do is take the two equations and subtract them from each other. See, this is taking the equation of f and the equation of g and subtracting. But here, my friends, look at the mistake I make. Oh no, this looks like I'm subtracting the second expression, doesn't it? You know, I'm just taking my first expression and subtract the second, but it's subtracting the whole expression. So what this is gonna mean is that this negative gets distributed, so it's negative x squared minus 4. So I'm going to get a lot of you writing this equation like negative x squared, and we like to put the big powers in front, plus 2x. But you're going to make your mistake right here. You're going to make it. You're going to have that as a plus 4, and that's going to make your last term not the correct answer, which is negative 7. So again, be aware that when you subtract these two functions, that you subtract them, and when you do so, you distribute that right there. All right, now, there's two ways to do this problem. Now, I will show you the way I did it on the answer key, but I'll just show you another way to do it too in case you like it better. Now, we are subtracting the two functions, so 2x minus 3 minus x squared plus 4. But you'll notice that this number is a negative 2, which means that we're going to plug that in for every instance of x. So, look at my equation now. It's time for order of operations, folks. The first thing we need to do is parentheses, and we are going to do those parentheses first. Exponents in the parentheses, so we have 4 plus 4. So this is minus 8. Now over here we have negative 4 minus 3. Negative 4 minus 3 is going to be negative 7. Negative 7 minus 8, negative 15. Know your order of operations, folks. But I want to show you this other way to do the problem. Let's say we plug in our negative 2 in for each of these expressions here. So this is going to be 2 times negative 2 squared minus 3. So this is going to be 2 times 4 minus 3. Oh, wait. I just made a mistake here. Okay, let's start over again. So this is going to be 2 times negative 2. I put a squared there, and that was not for the f of x. Okay, so 2 times negative 2 minus 3, which is going to be our negative 4 minus 3, which is our negative 7. Now see, we can do each of these separately and then combine them as long as you make sure to subtract the two numbers. So this is my g of negative 2, so negative 2 squared minus plus 4. So it's going to be 4 plus 4, which is 8. So negative 7 minus 8, you see we get the answer of negative 15. Doesn't matter which way we do it, whichever way you'd like to do it is up to you. But I wanted to show you both methods here. Well, you've made it, folks, to the end of the 4th video. The last video is short, but it's very important. Don't skip it. All right, thank you for watching.